Yes.
Good morning and welcome to HACS Engineering Career Day. We're thrilled to have you join us this year. My name is Kim Kettleslager and I teach the engineering and engineering technology students at Harrisburg Area Community College. I'd like to thank you for joining us today, and I'd also like to thank the industry speakers who took time out of their busy schedules to share their field of engineering, and also the HACS staff and faculty who work so hard to make this event happen. I have with me today my colleague, Melissa Harden, Dr. Karen Borgs-Miller, a chemical engineer from Johns Hopkins University, and two HAC graduates that currently work in the field as engineers, Kevin Brown and Megan Bartholomew. Our job today is to share as much as we can about the fascinating field of engineering in 3 hours. Your job is to learn, ask questions, and have fun. Please post all of your questions in the Q&A box. Some will be answered immediately, and others will be addressed at the end of the presentation. When I was your age, I knew very little about what engineers did. I grew up in Newport, Rhode Island, and enjoyed math, science, and I took 4 years of mechanical drafting. When I graduated from high school, I attended my state university, University of Rhode Island. My major was pre-dentistry with a minor in math. What's funny to me now is that one of my least favorite things to do is to go to the dentist. So I couldn't imagine being a dentist. In my second semester of college, I was taking Calculus 2 with all of the engineering majors. And one day they asked why I wasn't in the engineering classes. So I asked them about engineering because I really didn't know what they did, and they explained it to me. And the next semester, I tried a few classes and I loved it. So essentially, I fell into the field of engineering. I ended up graduating with my bachelor's in mechanical engineering. 2 years after I graduated, I went back to the University of Rhode Island for my master's degree in manufacturing engineering, part-time while I was working full-time. The master's program focused on design for manufacturability and design for assembly, and I learned skills that I could apply to my job the next day. The nice thing about taking classes towards my master's while working full-time was that the company that I worked for paid the tuition. And after taking classes and working for about 3 years, I took a leave of absence from my job and went full-time because my professors offered me a paid assistantship and the opportunity to write my thesis for General Motors in Detroit, Michigan. The graduate assistantship was not as much as I was getting paid working as an engineer, but the cut in pay was worth it to get that experience and learn more about General Motors, and also to finish my master's in 9 months versus another 4 years. So I ended up getting my master's degree in manufacturing engineering. My first job was with Hasbro Toy Company. I worked there for 2 summers before I graduated and 2 years after graduation. I worked as a drafter for senior engineers, and I got to work on the G.I. Joe aircraft carrier and the Play School flashlight. My second job was with Stanley Tools. I worked for a division called Bostitch as a development engineer designing pneumatic nail guns. During my 4-year employment with Bostitch, I took 1 or 2 classes in the evening towards my master's degree. Once I graduated with my master's degree in engineering, many opportunities became available, and I got a job on the West Coast in Eugene, Oregon, as an optical mechanical engineer designing barcode scanners. I worked there for 4 years, and after having my first child, we wanted to live closer to our families, which were in Rhode Island, Connecticut, and Maryland. So I got in touch with my professors and told them that I was interested in relocating to the central Pennsylvania area. I got a job with AMP, which is now TE Connectivity, and they relocated us. I was employed with TE Connectivity for 7 years as a development engineer and designed lots of different connectors. I worked in industry as an engineer for a total of 17 years and have been awarded 8 patents on products that I designed. After working as an engineer for 17 years, I took a detour to teach the engineering and engineering technology students at Harrisburg Area Community College. So my engineering education provided me with two careers. My first career as a design engineer and my second career as an engineering educator, both of which I have completely enjoyed. Okay, so let's get started. What is engineering? Engineering offers more career options than any other discipline. It's a profession that can take you from the deepest depths of the ocean to outer space, from within the smallest microscopic structures of the human cell to the tallest skyscraper. Whether it's cell phones, cameras, DVDs, or designing facial recognition systems that can pick out a terrorist in a crowded football stadium, engineers are behind almost all of today's exciting technology. An engineer is someone who applies the principles of math and science to a product or process. They turn ideas into reality. Engineers are problem solvers. They make things work better, more efficiently, for less money. They serve humanity, searching for better ways to solve problems, relying on their creative and academic skills. Engineers come in all shapes and sizes, nationalities, genders, and maybe even you. What do engineers design? Engineers are responsible for every single thing that Americans would identify with their high quality of life. Computers, MRI scanners, automobiles, iPhones, yet only 61% of Americans are, quote, not very, or quote, not at all familiar or informed about engineering and what engineers do. At this time, I would like to introduce my colleague, Melissa Harden, who will share her engineering career and exciting engineering innovations with you. Thank you, Melissa.
Thanks, Kim. Hi, everyone. My name is Melissa Harden. I'm happy to be with you here today. So I just wanted to start with really what inspired me to be an engineer as well. My path was just a little different from Kim's. So growing up, my dad is an engineer. He's a mechanical engineer, and my two older brothers were in school for engineering as well. My one brother is aerospace, my other brother is mechanical. So I was around a lot of engineering, thought processes and people who really understood engineering. And I really enjoyed math. That was my favorite subject. And science I liked enough. So I decided to go into engineering. So then the real question was, what discipline should I go into? Because there's so many disciplines, really wonderful disciplines to choose from: mechanical, civil, electrical, chemical, industrial, material science. There's so many different fields to go into. And so the little image that I have up there with the target, that's really what I really wanted to focus on: improving processes and in working with people and trying to make things more efficient. So that's why I decided to major in industrial engineering, and I earned my bachelor's degree at the University of Buffalo in industrial engineering. So now I've graduated. Now, what do I do now? Okay, well, I had a choice. It was sort of at a crossroads. I was offered a full scholarship to get my PhD in operations research at the University of Buffalo. I also was interviewing, and I was offered a full-time job at a company called AMP Incorporated. into their rotational program. And at that point, I was sort of ready to be done with school, to be honest. So I just wanted to start applying what I learned. So I went ahead and took the full-time job at AMP Incorporated. And I went into their rotational program, which was wonderful, wonderful program where I rotated through all different engineering positions. So I did industrial engineering, materials, manufacturing engineering. I worked in quality. I also did product engineering where I helped design some products as well. So the products that you're seeing there, the pictures there, those are some of the products that I worked on while I was on the rotational program. And I was able to get 5 years worth of experience just in those 2 years. It was a really wonderful, wonderful program. So during this time though, I really discerned more what I really wanted to focus on. And I really had a passion for manufacturing engineering. I just loved it. I loved working with the people. I loved working in the shop. I loved the hands-on aspect of working with tooling. So I decided to continue my education to specialize in mechanical engineering. So I went to Penn State Harrisburg and I earned my master's degree in engineering science. The nice thing about that program was that you could specialize in the area that you were really interested in. So I took all my graduate level courses were in mechanical engineering and my thesis was in mechanical engineering. So it really offered me that academic, a little bit deeper academic background that would really help me in my manufacturing engineering pursuit at AMP. So earning that degree really helped me pursue and open more doors at AMP so that I could do more of the mechanical design, manufacturing design. So just a few things here on this slide. I just want to go through sort of my journey into my different jobs that I've done over the years. So at AMP, I worked as an IE industrial engineer, as well as then I moved into manufacturing engineering. Then it changed. Tyco Electronics bought AMP. So now it was the same sort of company, but we had now some more divisions. And I moved into manufacturing development engineering, where now I was able to design processes and products. And I worked really heavily in design for manufacturability. So working with product development to design products so that they could actually be manufactured. And then I moved into a project management role and an engineering manager role. So I had teams of engineers that we worked together on new products and developing new processes. And during that time, I started teaching at HAC as an adjunct and part-time in the evening, and I just loved it. And I always really enjoyed working with new engineers coming in. So I was a mentor at TE for new engineers. And so the teaching just fit really well. And so I have now been full-time at HAC in the engineering and engineering technology department since 2017. And I just really thoroughly enjoy working with students, helping students who are really interested in engineering, pursue their goals and be successful. So another benefit of engineering when you work in engineering is it's a global career. So you're able to work with people all over the world. And I had the opportunity to travel to many countries during my time at TE. And you can see there some of the countries that I traveled to. And it was just a wonderful experience to be able to learn different cultures, work with engineers around the world. And it really did help me become a more well-rounded and diverse engineer. And that collaboration really led to a lot of great design innovations for our company. So I just want to now go into some other innovations that engineers have made to really help with both design and manufacturing. And the first one here is the collaborative robots. And if you've seen robots, I'm sure many of you have seen robots where, you know, they can weld, they can do almost anything. And a lot of times with these robots, you need to have really strict guarding around the robots, or you can really get injured if something goes wrong. So the innovation of collaborative robots really changed manufacturing, because now these robots have sensors around the outside that humans can actually work right next to, just like this picture here. And so you can have those robots doing more of the repetitive tasks that aren't really good for humans to do. So then you can work right next to them though, and you don't have to have all of those restrictions around the guarding and that. Now, those other robots still exist and there's still many applications for those, but this is a really nice innovation to help integrate that into manufacturing. And you may have even seen these robots, like you see robots maybe in your grocery store, you know, that's in a collaborative robot. And if you get close to it, it'll stop. Those, you know, robot vacuums, that's a type of collaborative robot as well. Another innovation that really started making headway, it's been around a long time, but really started getting integrated a lot about 10 years ago, is 3D printing or additive manufacturing. And I'm sure many of you have seen 3D printing and even have done some 3D printing yourself on a small scale. But 3D printing now is really come a long way. And in fact, just last month, the Habitat for Humanity just built their first 3D printed home out of concrete and in Williamsburg, Virginia. And they're now working on another one in Arizona. So it's really exciting, really an exciting field to look into. And there's customization of prosthetics and even 3D printing organs and food, and you name it, you can probably 3D print it. So that's really made a lot of changes in both design, so you can customize things much quicker, as well as helping with manufacturing and really helping to reduce that time to market to get products to market faster. The next innovation, and you may even have seen these or even own them. I have had students that have owned these, Nike's self-lacing shoes. And it's not really just a fun thing. It really can help improve the quality of life for people who can't tie their shoes. Some people, they may not be able to bend down and tie their shoes. So this is a really good innovation, really exciting too. That's also fun. So some other innovations, the next innovation is sort of a future innovation, micro homes. And you've all seen, I'm sure, the tiny homes, but this is a little different. This is really in the cities where there is really constrained living and there's not much space, like think New York City or Hong Kong, where you can use those tiny little spaces in between buildings to put little micro homes that can be used to help combat some homelessness. If there's, in the winter time, if people need a place to stay for the night, this is a really nice innovation that can really help improve the quality of life for people in those cities. So now I'd like to introduce Kevin Brown, who is a HACC graduate in the mechanical engineering technology and structural engineering technology programs. And Kevin will be talking to you about some of the various engineering disciplines that there are. Welcome, Kevin.
Thanks, Melissa. Yep, my name is Kevin. I am a graduate of Hack. I started in 2020, well, not I started, but I went for about 4 years and was started as a straight mechanical engineering student, was working through some of the gen eds. And once I kind of got into it, I learned about the Associates MET program and transferred to that, which was something that I felt was going to give me a little bit more of an applied, a little bit more immediately applicable knowledge, and also only a 2-year program. So I transferred to that, and I worked with Kim, who's one of my professors, and got involved with T connectivity as well, doing the 3D printed stuff for an internship. So in 2018, I graduated, and because I had transferred and got a 2-year degree, I was able to get a job right out of classes in 2018. So now I applied online and got an interview again at Fleming, which is a civil engineering firm in Camp Hill, and was supposed to be doing bridge drawings, kind of related to my field of study at that point. So they ended up transferring me. They said, we have a different opportunity, and I was introduced to environmental acoustics, which is where I'm at now. And my roles involve studying noise and vibration in regards to civil engineering projects, which can be construction demolition or utilities, or most of our work is highway transportation noise, trains. And so oftentimes you'll see the noise walls like all over the side of the road. My job is to study the traffic predicted noise levels, and then determine where the walls go, how high they need to be, and deal with like the back end of that stuff. So technically my position is an environmental noise and vibration consultant. So we get a little bit of vibration as well, working with like trains or again, like demolition. So some of my responsibilities would be like to analyze civil drawings, plan views, perform like noise sampling and surveying, going out in the field and seeing what we hear. We determine the feasibility or if we can, environmentally, place noise walls strategically without impacting the environment. And yeah, some of the benefits of working here, I kind of get to travel a little bit. I have some flexibility. And then one of the main benefits of working for Gannett Fleming, and really the reason why I got on, was to continue my education. So I'm continuing my education out at Penn State Harrisburg for my bachelor's in structural design and construction engineering technology. And so that is company paid at this point, which so Gannett Fleming's been both a great home and a great stepping stone for me to continue my education. And it also, Hack having a strong program, it has, even with a 2-year degree, was enough to prepare me for a really stable career. So I'm going to go over some of the types of engineering. And so yeah, engineering is a huge field with many disciplines, such as chemical, civil, electrical, mechanical, and other specialty fields. And we're just going to go over each one of these individually. So chemical engineers, which apply the principles of chemistry to solve problems, including the production or use of chemicals or other products. They manufacture medicine or paint, food processing, or make equipment that would prepare snow at Ski Round Top or other ski resorts. There's a local company that commonly hires mechanical engineers in the central Pennsylvania area, which is Hershey Foods. Civil engineers design and supervise the construction of roads, bridges, airports, tunnels, dams, water supply, sewage systems, and I guess noise walls too. They must consider many factors in the design process, from the construction costs, expected lifetimes of a project, to government regulations and other environmental hazards such as earthquakes and hurricanes. Electrical engineers design, develop, test, and manufacture electrical equipment. They work with things that use electricity, involve chip design, software development, and they're often concerned with making things run faster, more efficient, and using less power. Mechanical engineers, this is one of the broadest engineering disciplines. They research, design, develop, manufacture, and test tools for engines, machines, or other mechanical devices. They work on power producing machines such as generators or power using machines like robots. Mechanical engineers are involved in a wide variety of products from engines, gears, robotic arms, or even roller coasters. Other types of engineering, which are not as common, but equally as important, would be architectural engineers, aeronautical engineers, safety, computer, biomedical, nuclear, environmental, and packaging engineers. And I am going to hand this off to Megan, who is going to explain her work at Phoenix Contact and cover the next few slides.
Thanks, Kevin. Hi, so as Kevin mentioned, my name is Megan, and I have an associate's in mechanical engineering technology from HAC. And I also completed my bachelor's degree in mechanical engineering technology at Indiana State. I work for Phoenix Contact, which is a company that makes industrial electronics. So things that might be behind the scenes, but making everything work, things that operate rides at Hershey Park, or stop the gas from pumping at the gas station. Lots of different industrial uses, but I work in the design and development of new products. So I work from the concept phase to the prototype phase to the end customer. And it's really great to see my ideas come to life through CAD design and drawings to 3D printed, and then eventually, injection molded, or however it's created, and then it goes into the customer's hands. So it's a really awesome field to be in as a mechanical engineer. The company is a great place to work for, and they've actually paid for me to get my bachelor's degree. So, that's an awesome opportunity that I've had. So I'm going to talk about different types of engineering, and it's definitely a team effort, and each type of engineering can be broken down into groups of engineers. So there's engineers, there's engineering technologists, technicians, craftsmen, trades, and they all work together to test, design, build, and manufacture products. And as you move up from trades to engineers, the hands-on work and the hands-on work decreases, and the applied math increases. So different advantages of an engineering degree. At my company, we have engineers all across the board in our sales department, in our research and design, marketing, project management. There's so many different places that you can use your engineering degree. And according to the US Bureau of Labor Statistics, as a group, engineers earn some of the highest average starting salaries among those holding bachelor's degrees. So why does a degree in engineering matter? Well, the job growth and number of jobs are faster than average across many engineering disciplines. So here are a few of the greatest growth and number of jobs. So civil engineering, electrical, mechanical, industrial, as you can see, they're all growing anywhere from 2 to 10%. There is a great need for engineers in all disciplines, so it's definitely a wonderful career to pursue. So as you can see, compared to the median income across the entire US job market, engineers make a significantly higher salary and have security in their job. So there are many different types of job fields that engineers can get involved in. Graduates with an engineering technology degree often work in job areas along the left side of the chart, while graduates with an engineering degree often work in jobs along the right side of the chart. There's a large overlap, as you can see in the middle, where graduates in both engineering, technology, and engineering may work. So when I first started with my degree at my current company, my position was leaning a little bit more towards the left in component design and more like drafting with little testing or evaluation. But the longer I've been there and the more that I continue my education, my job seems to head towards the right of the graph. So many engineers apply their technical knowledge in completely unrelated fields. Guy Bluford was an aeronautical engineer and US Air Force officer and fighter pilot. Iocca was an industrial engineer, president of Chrysler, and best known for his involvement in designing the Mustang. Tom Schultz was an MIT graduate in mechanical engineering and the founding member of the legendary rock band Boston. And Mike Bloomberg, an EE from Johns Hopkins University, he founded a financial and media company, was the mayor of New York City for 3 terms, and ran for president in 2020. Lots of other people too. In fact, the American Association of Engineering Societies estimates 30% of all American CEOs are engineers. Engineers also get involved in teaching, technical sales, pharmaceutical sales, and as stockbrokers in the stock market. Okay, so could you be an engineer? The engineering field is a great place for people who take stuff apart and figure out how things work. Engineering is essentially a hands-on science. We apply math to real-life problems. So here are a few questions you could ask yourself to see if engineering would be a good fit for you. So do you like doing new things? Do you want to know how things work? Do you read up on how they create special effects in films? And do you like to know why? So HEC is, obviously an amazing school. I wouldn't be here today if I didn't support it. But there are a lot of advantages that HEC can offer versus a traditional 4-year college. So obviously it's financially affordable. I was able to pay for my 2-year degree much easier than I was if I would have had to pay for a degree at a 4-year college. The credits transfer to schools. I was able to take my general education classes for my 4-year program at HAC, and I stayed there until they basically kicked me out and said, you've taken everything you can, like you have to go. There's also a low faculty to student ratio, which I cannot stress how important that is. Kim and my other professors were always available to answer questions. I had a great relationship. They knew who I was, and I didn't have the same experience at some at the 4-year college I went to. It wasn't quite as personal. The guidance I received was amazing. It's actually how I got my job now, because my professors thought of me when companies were reaching out to HAC and saying, hey, we need employees. They had some students on deck, and I was ready to go. And then I was able to leave with an associate's degree. I know that, you know, the curriculum really integrates projects that are relevant to the current industry out in the community, which is also helpful for when you're looking for a job. And, you know, students are definitely satisfied. I can speak from personal experience. The labs are great, and there are also scholarship programs. Okay, so what the HACC engineering faculty offer? HACC instructors are committed to helping students acquire the skills and knowledge necessary to launch a successful career or transfer to a four-year college. Quality education at an affordable price. All right, so thank you for taking time to listen to me today. And next up, we have Dr. Karen Borgsmiller, and she's going to tell you about the exciting opportunity for high school students interested in learning more about engineering.
Good morning, everyone. I'm Karen Borgsmiller, and I am currently the Director of the Engineering Innovation Programs at Johns Hopkins University. We have partnered with the HACC Harrisburg campus in the past to bring this opportunity to high school students in the Harrisburg area. So it's always nice to connect with my Harrisburg friends on this engineering day and catch up on what everybody's been doing. I will just briefly talk. I have a bachelor's degree in chemical engineering, and I went to work after graduation for Exxon. And what I will say is that an engineering career prepares you to answer questions that are not in your textbook. So you go through your textbook and you do problems, all the problems in the back. When you get to your first job, there's not going to be a problem in the back that with the answer key. It's going to require you to take everything that you've learned and combine that in ways that are different and unique to the question that you're answering. And so when I went to work at Exxon, my first career, that was what struck me first was this is different, but it's fun. And my education prepared me well to do this. And what was great about being at Exxon as a young person, like Melissa, I got to travel. So that was good fun. Like everybody here, I think Exxon paid for me to work on my master's degree part-time. And so I was doing that while I was working. It was a great way to test the waters as to whether I wanted to go back and pursue my PhD full-time, which I did. I left Exxon after 2 years and went on to Georgia Institute of Technology to work on my PhD. My Exxon work was environmentally focused. I'm a chemical engineer. I worked on some really interesting environmental projects. When I went to graduate school, I changed gears and I used my chemical engineering to look at pharmaceutical projects. What can we do to manufacture pharmaceuticals? It was a little bit of environmental in a way that was more environmentally friendly. And so the breadth of things that you can do, you don't have to narrow yourself into one narrow stream of focus. There are so many opportunities that the degree will allow you to explore. I left Georgia Tech and started teaching. That's what I wanted to do, and finally ended up at Johns Hopkins, which I'm thoroughly enjoying, preparing engineering curricula for high school students to begin to think about whether this is something that you want to do full time. So let me talk about our program. We have 2 courses that we offer currently. One is called Explore Engineering Innovation, and that is a 4-week in-person course this summer, but we will not be in person at HACC this summer. We will be doing a 5-week online version for the students in the Harrisburg area. And we also offer a biomedical engineering innovation. That is a fully asynchronous online offering, and that is a 6-week program for this summer. And they're very similar, very highly project-based. They are fun, they are engaging. You get to work with students from other schools, other states, other countries in some cases while taking these courses. The Explore Engineering Innovation is very broad. We do activities in civil, electrical, mechanical, materials science. There's a chemical engineering project. It culminates with building a bridge out of spaghetti. After you have tested the material properties of spaghetti and learned how to resolve forces in a bridge truss, the culminating project is a bridge out of spaghetti. And this is not cross your fingers and glue popsicle sticks together kind of project. You're doing a lot of math around and physics, using those skills to build this bridge. Our best bridge ever weighed 250 grams. So that's like what, a quarter of a pound, and held more than 200 pounds of load in the center. So it's pretty impressive what we can do. The biomedical engineering is also multidisciplinary, but biomedical engineering is a field that really can require knowledge of electrical engineering, materials science, all of the various disciplines. And so that's also nice. The lean here in this course is on solving problems with physiological or biological questions, as opposed to the Explore Engineering. If you take these courses, there's an opportunity to earn 3 Hopkins engineering electives. And certainly, if you want more information, ei.jhu.edu. I think it says fully online for summer 2021. We will be fully online in the Harrisburg area for 2022. And that's spending your summer doing engineering enrichment activities is only one way that you can prepare for college. Other things that you can be doing are exploring dual enrollment opportunities with HAC Harrisburg. There are many opportunities, possibly with your high school, to get both college and high school credits for the same course. Take drafting classes if your high school has those. Computer, math, physics, all very important. Take as many math and science classes as you can. Calculus is not required as an entry level for an engineer. Just know that you want to have the strongest math skills because you're going to continuously use those and build on those. So it's more important to have a strong foundation because you will have the opportunity to take the math classes and the science classes that are needed for your degree. Then think about English and humanities and your extracurriculars. I always joke that one of the reasons I applied to Georgia Tech was I didn't have to write an essay to be accepted into graduate school. And that was true. But engineers really do need to be able to write. They need to be able to communicate. Your technical ideas will have to translate to the broader community. You will need to work with folks on your design teams that don't have technical degrees. Your sales and marketing people may not have those backgrounds to talk the technical talk. So being able to express yourself orally and in a written way is very important. And the ability to connect with people is also across these various teams is also important. So you will use your math, you will use your science, you will use your engineering, you will use your communication skills and your people skills. All of those will be important for you. There are so many ways for you to learn about what different engineers, you're already here, you're participating in Engineers Week. That's a great start. The Engineering Week website has a lot of activities and information, and also gives you snapshots of what different engineers can do. You can look at Discover Engineering. Each engineering discipline has their own professional organization. So the American Society of Mechanical Engineers, the American Institute of Chemical Engineers, there are so many that if there's a field that you're interested in, find that professional organization website and look at what are the new and fun things that are happening in that discipline. The American Society of Engineering Educators, that's the last checkbox. The check mark on the last on this list of sites is another great resource. High school guidance counselors have opportunities and know of opportunities in your community for you. Certainly reach out to them. And Kim and her staff, top notch. They really are interested in supporting students the whole way through their development. So from pre-college all the way through, as you heard, both Megan and Kevin say that opportunities even after they left Hack were provided to them through their experience at Hack. So thank you for listening to me. What I want to do is I want to turn this whole conversation over to Abdurrahim Kirchtu, and he will talk to you about what is happening at Hack.
Thank you, Karen. Hello, everyone. My name is Abdurrahim Kirchtu. I am one of the admissions counselors at Hack. Now that you have heard this detailed information and hopefully inspired by especially Kevin and Megan's story and their great experience at Hack, I trust that you will be better equipped and ready to start your career at Hack. As you can see, our admissions process is easy and straightforward. We encourage you to visit hack.edu/getstarted to learn more about us, submit your application online, and provide us with your high school transcript. You can then complete your free application for FAFSA online, which is the application for federal student aid, to see the type of financial aid available to you. Then you will move through the Hack steps of activating your account, completing placement testing if necessary, attending new student orientation, and meeting with an academic advisor to register for classes. For those of you who are interested in taking Hack classes while in high school, juniors and seniors have an amazing opportunity to participate in our dual enrollment program. The application process is similar to general admissions. However, you should select dual enrollment as your program of study. And of course, you always need to have that conversation early on with your high school guidance counselor, because you want to be able to be taking college courses that can also be used towards your high school graduation. So it's a great way to get a head start and be introduced to the college experience. You still also have the flexibility to take classes on campus via virtual learning, remote instruction via Zoom, or a combination of these. You can also take advantage of our services, such as tutoring, success coach, advising, and career services, whether that be in person or remotely. And most importantly, you are going to benefit from a significantly reduced tuition cost. So just think about this. Current tuition for in-state resident student is $276.50. That's already a low tuition rate. And while the dual enrollment tuition is $127.50 per credit. As a high school student, dual enrollment program will enable you to earn college credits to continue on at Hack after you finish your high school, or basically you can just transfer to a four-year institution. We have articulation agreements with over 40 schools, 40 colleges and universities in the state. And some of them are the patchy schools, like Millersville University, Shippensburg University, and Kutztown. We also have agreements with non-patchy schools such as Penn State, Temple, and University of Pittsburgh. So if you have any questions on the admissions process at Hack, our programs or application, please feel free to reach out to us at start@hack.edu or give us a call at 717-780-2400, and we will get back to you as soon as possible. Thank you so much for spending time with us today. This actually concludes our presentation for this session. So if you have questions at the moment, and we hope that you do, please submit them through the Q&A box in Zoom, and we will gladly answer them for you.
I actually have a question about the dual enrollment program. So you mentioned that you go through the same process as the general admission, but do high school students also have to fill out a FAFSA form?
High school, sorry, high school students are not permitted to be submit FAFSA application because they are not 18 yet. So they are still minors, so they cannot. However, we do have scholarships that they can apply for. And also they can participate in our HAC payment plan as well. Thank you for that question.
Okay, I don't think we have any additional questions. So I guess we will wrap this up. Thank you all for joining us today. And thank you again, Melissa, Kevin, Megan, Karen, and Ibrahim for joining us and presenting. Oh, there's one question. Okay, actually, we did get a question. As far as Cumberland Perry area students are concerned, are there dual enrollment opportunities? Yes, there are. There's also something called college in the high school, and your guidance counselors can tell you more about that.
Yes, definitely. There are two options. So basically, you can consider dual enrollment, basically taking classes at HAC with HAC students, with college students, or we have some schools, you need to check with your high school, that actually participate in what we call CHS, college and high school courses that are taught by faculty or teachers who are actually approved by HAC, and students actually take classes at their high school and actually earn credits, HAC credits for them.
Yes, in Cumberland Perry area of a technical school, they do offer college in the high school for many of the programs. The next question is, does HAC have any classes related to aerospace engineering? So what HAC offers is the first 2 years of all engineering transfer programs, which include lots of gen eds like English and speech and philosophy, history, lots of math, calculus 1, calculus 2, calculus 3, and also physics, 2 semesters of physics and chemistry. They also have an orientation class. And during this orientation class, it's a 2-credit class, it helps you to learn all about the different types of engineering. So that would be the closest, that would be related to aerospace engineering. And each student researches the fields. They need to do 2 fields that interest them the most. The other engineering classes that the first 2 years you would take would be a CAD, computer-aided drafting class, statics, and dynamics. So once you transfer to your school, college, or university, your junior and senior year is where you will start taking all of the specialized classes for either mechanical engineering, if you choose mechanical engineering, or aerospace engineering, if that's your choice. Okay.
I have another question, actually. Oh, we have another one. I was just going to ask how many credits high school students typically take as a dual enrollment student.
The ones that I've had, and I've had many in my classes, usually they'll take 2 classes. And that might be what we always recommend, math, to take the math class. But also they'll join me in my engineering orientation classes or the computer aided drafting classes, but usually they'll take one or two, most commonly two. And whatever classes they take, like the math class, will be applied to their math requirement at their high school.
Yeah, and that's an interesting question because I also have many of the dual enrollment students, and I've had two students, at least two, that have actually completed the entire engineering associates program while in high school. So they actually graduated from high school with the engineering associate's degree, and really that fast tracked them through into their bachelor's degree program. So depending on some of those students were homeschooled, so they maybe had a little bit more option to taking some hack classes while still in high school, but it is possible. So yes, it's more common just to take a few classes in your junior, senior years, but some students really take it full time and really go through the whole program. So it is possible. So really, it really is all possible. Yeah.
The next question is, what is the process like going outside the US to work in another country? Well, I've had many students complete their associates in engineering and then transfer to Rochester Institute of Technology. It's a great school. And they have a required internship program. And many of the students, their junior and senior year, they have to apply for these jobs, but many of them are outside the country. So it is common for engineers to get their bachelor's and be able to be employed in other countries, a bachelor's from the United States. Are there any other questions? These are great questions. Thank you. All right. Well, I think at this time we're going to wrap it up. But again, thank you all for joining us. It was a pleasure. We hope that you've enjoyed the hour-long presentation. And if you have any questions, feel free to reach out to Melissa or I. We could even put you in contact with these other speakers if you'd have a question specifically for them. So thank you again and take care.